morning, dear Shem Stars. How are you all, students? I hope you all are safe at your home. Students, today we are starting with the new topic, that is chapter number 10, circles. So let us see its introduction part first. So here in this chapter we are going to cover the following topics, that is first the introduction to the circles. Then the second topic is tangent to a circle, in which we will be studying the theorem 1, that is the tangent at any point to the circle is perpendicular to the radius through the point of contact. Second, a line drawn through the end of the radius and perpendicular to it is a tangent to the circle. Number of tangents from a point on a circle. So its theorem is the lengths of the tangent drawn from an external point to the circle are equal. And next is, if the two tangents are drawn to the circles from an external point, then they subtend equal angle at the center and they are equally inclined to the line segment joining their center to that point. So here we are going to see the proof of only one theorem, and rest theorem we need to revise for the questions. Now first, the definition of the circle. The set of the points in a plane which are equidistant from a given point, that is center of the circle, or you can say the locus of a point. Locus means path of a point which is at an equal distance from a fixed point. Next is the radius, a segment from the center of the circle to a point on the circle. So that is the radius. You all know what is the radius. Next is the circumference. The distance around the edge of a circle is known as its circumference. Then when we say the two circles are congruent, so two circles are said to be congruent if they have the same radius. So I hope you have understood what is circle, radius, circumference and congruent circle. Next we are going to see what is tangent and secant to a circle. Now first, what is the tangent? Tangent is a line that intersects the circle at only one point, and that point is known as the point of contact. Students, as you can see TG, this T is the point of contact which is perpendicular to the radius of the circle, and TG is the tangent to this given circle. So remember that tangent is that line to a circle which touches the circle at only one point, and that point is known as the point of contact. So TG is the tangent, the point of tangency is the point T, that is also known as the point of contact, and OT is the radius of the circle, and OT is always perpendicular to TG. Next is the secant, a line that intersects the circle at two different points. Here as you can see ES, E and S are the two different points where this line is intersecting the circle. So this ES is known as secant line. So again I am repeating, tangent is that line which touches the circle at only one point, and secant is that line which intersects the circle or passes through the circle at two different points. So next the theorem is the lengths of the tangents drawn from an external point to the circle are equal. Students, we need to remember this theorem as well as its proof also. This is a very important theorem from this chapter, whose result as well as proof we are going to use again and again. So let us do its proof first. So what is given to us over here? So here as you can see in the figure, we are given with the circle whose center is O, and P is any point which is lying outside the circle, and the two tangents, that is PQ and PR, are drawn to the given circle. So here what is the construction work? Join P to O. And what we need to prove here? We need to prove PQ is equal to PR. So by construction we will be joining O to Q, O to R and O to P. So as PQ is tangent to this given circle, so that means OQ will be perpendicular to PQ. So which implies OQP is 90 degree. So hence OQP is a right angled triangle. Next students, I want you all to try its proof by yourself. I'll tell you how you are going to do this. So here, as you can see in the triangle PQO and PRO, PO is common between the two triangles. OQ is equal to OR as the radius of the same circle, and angle PQO is equal to angle PRO is equal to 90 degree. So hence by RHS both the triangles are congruent and we will get the required result. I am again repeating the same. In the triangle PQO and PRO, OQ is equal to OR, radius of the same circle. PO equal to PO, common to both the triangles. Angle Q, that is PQO, is equal to angle PRO is equal to 90 degree, which is also given to us. So by RHS both the triangles are congruent. If the two triangles are congruent, by CPCT PQ will become equal to PR. I want you all to try this proof and we will be discussing the same proof in our next AIS class. So just revise the same. That's all for today students. Do revise what we have done in the class, and if you have any query, please feel free to ask on the Google Classroom. Take care and have a great day ahead.